Check that out. 146.000 on a little walkie-talkie. These lamps are being powered by that walkie-talkie. Taking a closer look, you'll notice this has a very small wire going up and a very small wire going down. It has an antenna and a rectifier, and this is around about a 4 to 5 volt lamp in each of these lights. Now I have an IC705 running 5 watts connected to a very small, essentially 3-element Yagi for the 2 meter band, which is in this case 146 megahertz. I will start a beacon. There we go. So you may have seen other videos of a rectenna, wireless energy, where there's some diodes and LED, and they say, oh, it must be a red LED because the voltage is much lower. And somehow, you have to have the rectenna directly at the antenna. This is brilliant. The fundamentals are, as you can see here, you need at least 3 diodes in a row, and we're tapping the antennas into these points, and the power to the source is across the end. So the highest voltage, so think of this as series like 1 cell, 2 cell, 3 cell, and the LED panel. The ones I've just demonstrated actually had 4, but there was 2 diodes between the 2 antenna points. So one thing you may notice is these lamps are going off very well. These are the ones with 4 of the diodes in series. But let's just look over in that direction. Do you see that LED panel there flashing away? Well, that one has just the 3 diodes in series, and it's actually operating beautifully too. There is so much to be experimented with. If you imagine, for example, these lamps, the original version of these had a battery in them and solar panels. I've gutted them and done this. You could use an RF signal to charge them instead of a solar panel. We don't need just inductive charging. We can use RF charging. This is a whole new world, and I'm surprised we haven't actually been playing with this, or at least not in the public sphere.